our presentation is about QM342 project. So let's begin with group member.
Hi, my name is Mahasha Kusina Ghazali and my student ID is 2023469624. So I'm going to present about calculation, QM for window and conclusion.
Hi, my name is Nur Alisha Nabi Hazaki. My metric number was 2023815694 and my part was introduction, server and queuing system management use.
Assalamualaikum. My name is Nur Husna Ifa binti Syarizal. My student ID is 2023871264 and in this video I will explain about characteristics of selected queuing system, arrival characteristic, waiting line characteristic and conclusion.
Assalamualaikum. My name is Nurin Damia Insyirah binti Mak Nasir and my student ID is 2023635982. And in this video, I will be explaining about service facility characteristic, basic queuing system configuration, as well as formula.
For QM342 project, we choose EMAT24 to be our observation place. It was a convenience store that sold most of Korean food. It is located at number 23, ground floor, Complex Perniagaan Humairah, Jalan Humairah 1, Tanah Merah 17500, Tanah Merah, Kelantan. This shop is open on Sunday until Saturday, starting on 8 AM until 12 AM. We arrived there at 2:30 PM and starting our observation for the queuing system on 2:46 PM until 3:46 PM for 1 hour. For our observation, the number of the server is only one server. From the 1 hour observation, the server system that has been used in the shop was one cashier to take the order and handling the payment that has been made from customers. Then, they only have one kitchen staff which is food preparers for prepare the meals. Other than that, they also have one serving staff to serve the customers, packing the takeaway orders and handling the additional requests like extra paper bags. For the queuing system management use, the type of queuing management used was first in, first out, or known as FIFO. Next, the order process for this shop was self-server, where the customer approached the counter to place their order and the staff will assign a queue number via a printed receipt. The payment also is made upfront to simplify the process and helps to prevent delay. After the ordering process, the customer needs to wait for their order at the customer waiting area, where the customer needs to wait near the pickup area for takeaway or sit at their table. The staff will call the customer by number to mention that the customer's orders was ready.
Now there are three types of characteristic of queuing system, which is arrival characteristic, waiting line characteristic and service facilities characteristic. First, arrival characteristic. The size of calling population is considered infinite since the mart serves the general public with no fixed or limited number of customers. Next, the pattern of arrival at the system follow a Poisson distribution. For example, the average number of arrival per hour, which is lambda equal to 18 customers per hour. Lastly, behavior of the arrival is patient customer. Customer wait in the queue until they are served. Next, waiting line characteristic. The length of a line is unlimited because it has no endpoints. The second one is queuing discipline. The queuing discipline at EMAT is FIFO, which stands for first in, first out, and it means that the first customer who arrives is the first one to get served.
For this slide, it explains about the configuration and characteristics of EMAT24 Tanah Merah branch service facility. First, let's look at the configuration of the system. The system has a single server, which means there is only one service counter or one worker to serve the customers. It also has multiple phases, meaning customers need to go through more than one step before the service is fully completed. Next, we look at the service facility characteristics. The pattern of service follows an exponential distribution. This means the service time is random, but on average, it follows a predictable pattern that is commonly used in queuing system. The service rate is 18 customers per hour. This means the server is able to serve 18 customers in 1 hour, or roughly one customer every few minutes. Overall, this slide explains about how the service system operates, how customers are served, and how fast the service can be provided. So this is the list of the formulas used in the queuing system. First, we have utilization, rho. Utilization is given by lambda divided by mu. Utilization shows how busy the server is. A higher value means the server is busy most of the time. Next, the average number of customers in the system given by L. This formula tells us the average total number of customers, including those waiting and those being served. Then, we have the average number of customers in the queue, LQ. This represents the average number of customers waiting in line, not including the one being served. After that, we look at the average waiting time in the system, W. This is the average total time a customer spends in the system from arrival until service is completed. Lastly, the average waiting time in the queue, WQ. This shows the average time a customer spends waiting in line before getting served. For this system, the arrival rate lambda is 18 customers per hour and the service rate mu is 20 customers per hour. These values are used in all the formulas to calculate the performance of the queuing system.
So now, let's solve it using QM342. Now, for the first step, we need to see the left side, which is waiting line, and we pick the first one, which is M/M/1, because we are using single channel queuing model. Next, we change the title to group project, and for cost analysis, we pick no cost. Then, after all of that is selected, we click OK. And for this part, arrival rate lambda, we put the value 18. And for service rate mu, we put the value 20. For number of servers, we put 1 because at EMAT, they only use one server. And don't forget to change the time unit arrival and service rate to hours because we want to collect the data in hours. For the next step, click the solve button above. So, this is the result for our waiting line. Let's take a closer look in the next slide. Result for average server utilization, P is 0.9. For average number of customers in the system, L is 9.0. Average number of customers in the queue, LQ, the value is 8.1. Furthermore, the average waiting time in the system, W, is 30 minutes. And the last one is average waiting time in the queue, WQ, is 27 minutes.
For the basic queuing system configuration, IMAT24 Tanah Merah branch have a single channel system. Single channel means that there is only one line and one server at a time. All customers will have to wait in the queue before being served. This system is a multi-phase system. Multi-phase means the service is completed in more than one stage. After finishing the first service, which is in this situation, ordered their food, customers move on to the next service stage, waiting to get their food before leaving the system. As you can see at the diagram, customers arrive and join the queue. They are first served at Type 1 service facility. After that, they move to the Type 2 service facility for the next stage of service. Once all service phases are completed, the customers depart from the system. So, IMAT24 Tanah Merah branch is a single channel, multi-phase queuing system where customers are served step by step through different services stages.
For the conclusion, first, is the number of servers provided adequate? The number of servers is not adequate because the server utilization P equals 0.9 is very high, meaning the servers are busy almost all the time. When utilization is high, the system becomes congested and queues fill up quickly. Servers are considered adequate only when P less than 0.8, which prevents long queues and keeps waiting time acceptable. Are the customers happy with the waiting time? Customers are likely not satisfied because the average waiting time is 27 minutes in the queue and 30 minutes in the system, which is relatively long.
From this project, I realized that when servers are almost fully busy, queues grow quickly and customers end up waiting longer. Even a small increase in the number of customers can make waiting time jump noticeably if the servers are already overloaded. Adding more servers or speeding up service can help reduce queue and make customers happier. Overall, this project showed me how queuing theory can spot bottleneck and help business like EMAT run more smoothly. So that's all from us. Thank you.